Hello, Algebra 1. We're back with PA2 Last Check, simplifying expressions using the distributive property. Let's go ahead and see what we got. So not all these require distributive property, but that's our goal for this. That's our 3-level work. So simplify each expression, show work when necessary. Well, in this case, I've got a negative 7n and plus 6n. They both have the same variable. They both have n. They both have the same exponent, just to the first when you don't see an exponent on the variable. There we go. That just means 1. So they're both the same thing. We can combine these two. I ended up with negative 1n or negative n. It doesn't matter, whichever way you want to approach this. Number 2, I've got x minus 6 minus 4x. Well, I got two different things going on. I cannot combine things with terms with variables to terms without variables. So this negative 6 is just going to hang out here. I've got a positive 1x, a negative 4x. That leaves me with negative 3x. Negative 3x minus 6, that is as good as I can do right there. Again, I'll throw this one as an either or. Number 3, 2 plus 9x plus 3x minus 4. Well, I can combine the things with x's, so I'll do that. Positive 9x, positive 3x to give me 12x. Then I'll combine the things that are just my numbers here, my 2 and negative 4, to get minus 2 or negative 2. So 12x minus 2. Number 4 is where we start to get into our distribution, right? We're going to distribute this 8 through over here. 8 times x, 8 times 6. That 5x out front, though, that's doing nothing. It's just hanging out till you're all done distributing, right? It's going to sit on your couch eating Cheetos till you're done and you're ready for it. So 5x plus 8 times x is 8x. 8 times 6 is 48. And now we need to look, can we combine anything else? Well, yeah, because I've got this has x, this has x, that 48 doesn't, so we're done with that 48. That's just going to be a plus 48 at the end. But 5x plus 8x gives us 13x. All righty. Let's look here at number 5. It says 7 times in parentheses 5m minus 4, and then plus 8 at the end. Well, I'll tell you what, that plus 8, that's not in the parentheses. We're going to leave that alone until we're ready for it. I'm going to put that in the next line already. But I know I can distribute here 7 times 5n and 7 times, this is essentially 7 times negative 4, okay? So 7 times 5n is 35m. 7 times negative 4 or 7 times negative 4, negative 28, okay? I have something with an m, but nothing else with m. So that 35m, that's the best we can do right there. 35m, negative 28 plus 8. So if I go negative 28, come back 8, I'm still negative by how many? 20. 35m minus 20. All right. Number 6. Now we got some negatives that we're distributing through. We can still do this. That's all right. So this is like negative 6 times 8k, negative 6 times 7, and this minus 3, since it's outside the parentheses, we're not going to mess with. So let's throw a minus 3 down here for now. Well, negative 6 times 8k is negative 48k. Negative 6 times positive 7 is minus 42, or a negative 42. Now I look, can I combine things? So I've only got one term with k, so negative 48k. I've got negative 42 minus 3. So I've got negative 42, I go 3 more negatives, so I'm going to put negative 45. There we go, number 7. Number 7, it says 7 times 2x plus 1 minus 3. Well, let's distribute through what we can. 7 times 2x, 7 times 1, that minus 3 is just hanging out here. So 7 times 2x is 14x. 7 times 1 is plus 7. I can only combine the two things at the end, 14x plus 4. Good to go there. Number 8. Oh, here we go. This is a thinker. Remember, you can always turn subtraction into addition. Negative 5 minus 6, you could call this plus negative 6 times 5x and negative 1. So I'm going to essentially be distributing a negative 5x to both of these. This negative 5 out front, though, just hanging out. Negative 6 times positive 5x gives us negative 30x. Negative 6 times negative 1, negative times negative is a positive, and 6 times 1 is 6. I can't do anything with this negative 30x. There's nothing else to combine it with. Negative 30x, negative 5 plus 6 is plus 1. And you're saying to yourself, Mr. Braidman, what if I wrote 1 minus 30x? Is that still the same? And I would say, yeah, because the 1 is still positive, the 30x is still negative. That's still fair. That is still fair. Number 9. Ooh, distribution twice. Here we go. 6 times 4x, 6 times 7. Let's go ahead and do that first. So 24x plus 42 plus x times negative 3x minus 4. Ooh, now we got to distribute a variable through. Let's do that here and here. Well, I've got 24x still plus 42 plus x times negative 3x is negative 3x squared. So plus negative 3x squared. And x times negative 4 minus 4x. Now, if you remember back to some of our conversations, can you combine things that have x's with x squareds? Well, they're the same variable, Mr. Braidman, and I would agree, but they have different exponents. If they have the same variable but different exponents, you cannot combine them. They have to have the same variable and the same exponent. So this negative 3x squared, all by itself out here. Can't do anything else with it. I can combine 24x and negative 4x though to give me plus 20x. And then I've just got a number hanging out here. So plus 42. And that is how you take care of that. Let's go ahead and look at number 10. Number 10 says negative, a negative times 7v plus 1 minus 3 times parentheses 1 plus v. I promise you that there'll be something like this on the test. If you're paying attention, there's something like this on the test. If I've just got a negative on the outside, like we talked about in the guided notes, we treat that like a negative 1 because it is a negative 1. This is like negative 1 times 7v plus 1 minus 3 times 1 plus v. And if we do our distribution, negative 1 times 7v, negative 7v. Negative 1 times positive 1, minus 1. Distribute here and here. Treat this like plus negative 3. Negative 3 times 1, negative 3 times v. Negative 3 times 1 is negative 3. And negative 3 times v is minus 3v. Combine the things with v's because I don't have anything that's squared or cubed or anything like that. Negative 7v minus 3v, negative 10v. Negative 1 minus 3, negative 4. Show your work, show your work, show your work, show your work. If you make a small error in calculation, I can figure out where you've done. Is it just an error that you multiplied wrong or added wrong, or did you not have the concept down? Let's look at the 4-level question here. Is 3 plus x times y equal to 3 plus x times 3 plus y? Is that a true statement? Well, let's look. The left side, well, and we can drop the parentheses. This is just 3 plus xy. That right-hand side, though, we can do some distribution with that. 3 plus x times 3 plus y. So you could use the box method if you wanted to, or you could remember that you'd have to distribute the 3 to everything here and the x to everything here. It could look like 3 times 3 plus y plus x times 3 plus y. Already, this doesn't look good for being the same, does it? So if I distribute through here, 3 times 3 is 9. 3 times y is plus 3y. X times 3 is plus 3x. And x times y is xy. Well, here's interesting. I can't combine xy with x or xy with y. They don't have the same combination of variables. Well, they both have x's or they both have y's, but they don't have just an x or just a y, or both have xy. I can't combine any further. So we've just proven that no, it does not work because the left-hand side gives us 3 plus xy. The right-hand side gives us that big long thing. And again, don't forget the box method. You could have thrown this in a box, right? 3 plus x, 3 plus y, 9, 3x, 3y, xy. Get the same thing as you do here. Hope that helps. Take care. Have a great day.